In the mail this time, a few parts I ordered for projects came in as usual, and Banggood sent a bunch of parts to help sponsor a few upcoming project ideas. Starting with this Nema 17 stepper. It comes with a long cable and a DuPont style header on it, and it has a 300mm 1-foot lead screw and this nut on it. The lead screw is used anywhere that linear motion is needed to move a load, such as in 3D printers or CNC machines. So for example, if you attach something to this nut and then you rotate the shaft here, this item will just slide up or down. So I just had some ideas I wanted to prototype, and I thought this should be sufficient. And I have some extra parts, like more of these nuts for that rod, and also this other smaller rod with this anti-backlash nut on it. If I put this nut on here, backlash refers to the fact that there's going to be some play here, and if you tap it, you can actually hear how it's hitting against the threads, but it rocks back and forth. The anti-backlash, it can still move a bit, but it's nowhere near as sloppy. And also, if you go vertically with this, sometimes these can just free fall down, whereas obviously this one is staying put. With friction, it actually needs some force to move it. And if we take this off, the way it works, it's two separate parts with a spring in between. So when you let that go, these two halves go together, and when you put this spring in here and it's under tension, it will keep both of these against the threads, and it just makes it more stable. This is a 12-volt, 15-amp, 180-watt power supply, model S-180-12, and you can find a full list of features on the product page. It's intended for more permanent installations where everything is wired up and left alone, so the AC in and DC out connections are made with a terminal block and there's no power switch. Using these terminals gave me a chance to use the vintage crimp connectors that another maker sent me in a recent mailbag. The metal enclosure is perforated on top and on one side, which helps with passive cooling since there's no fan inside. There's a switch inside to change between 110 and 220 volts AC supply, and it can probably be changed by putting a non-conductive tool through the holes in the case, but I decided to take the case apart and look around anyway. The power supply design is based around the KA7500B PWM controller, and the power supply design looks to be a lot more elaborate than the basic application example in the datasheet, so let's see how it runs. I just want to do a quick test to see that everything is working. With the AC in and DC out connections made, I can see the chassis is earth grounded and the output is floating, so there's no earth ground there. With AC applied, the power LED comes on, and the output adjustment pot can vary the output from 11.7 to just over 14 volts. I also received a linear actuator to try out, and it has these DuPont pins on it. It doesn't take much current because it's so small, and so it's just got a couple of thin wires, and I've got all this hookup wire, which should be a good match for this when I use it in future projects. I have a dual relay module, which can be used with an Arduino or with switches for helping control this, and there's also these heavy-duty linear actuator mounts. They're basically a nut and bolt on this sort of hinge configuration. So this would mount to something, and then there's a hole on each end of the actuator. So in some applications, this can just be mounted on one end permanently, and this can slide in and out. But depending what you're doing, it may be good to just put it through the bolt here, and as it moves in and out, this may need to pivot. And these are a bit too heavy duty. These bolts are way too big for this actuator. So if I do want to use it with this, I'll just use a smaller bolt. But I plan to get more heavy duty actuators in the future, and that's when this will come in handy. Using the 12-volt supply, here's a quick test of the linear actuator using the dual relay module. I have it set up similar to this, except there's not a 9-volt battery, that's a 12-volt power supply. Normally there would be an Arduino controlling the relay board inputs, which need an active low to turn on the relay. For now I'm just using a switch to control each relay, so it's either floating or connecting to ground to turn on. This DC motor here represents the linear actuator, and it needs 12 volts to move. Depending if you have plus and minus one way or the other, it controls what direction the actuator moves. Once it gets to the end of travel, if power is still applied, there's built-in limit switches where it will turn off and stop moving, and you need to reverse polarity to allow it to move in the other direction. If power is removed while it's in motion, it will just stay in that position. The relay coils need 5 volts DC. I'm just representing that with a 6-volt battery pack, but this would be 5 volts. For this test, I'm not concerned about proper isolation here between the digital control input and anything higher power on the output. So the jumper here is set to share relay power with the digital side. Each terminal of the motor is going to its own relay in the common position, and the normally closed contact is connected to ground of the motor power supply, so when nothing's happening, the motor terminals are grounded and nothing moves. So depending if I turn on one relay or the other, I can connect each terminal between ground and plus 12 and control the direction of the motor or just make it stop. The actuator can be used to push, pull, lift, or lower a load, and this small actuator can only move small loads. So to test it out for now, I noticed it can push a stack of items totaling around 1.5 kilograms or 3.3 pounds along horizontally with whatever friction the top of this power supply is contributing. I also went shopping on Amazon. The first thing I bought is this set of M3 mounting hardware. I don't know if this is all going to fall out. Oh no, it's in a case. And these are hex heads, but they also have a ridge around there. They double as thumb screws. And the reason I wanted M3 hardware, that's what fits this stepper. So this will allow me to mount things here and put all of this hardware to use, and I can stabilize it on a platform or whatever I need to do. And this one is a monitor or small TV mount. So I bought this for a couple of potential uses. For one thing, when I get around to setting up a new workbench in the future later this year, I may just use something like this to mount on the back wall behind the bench. So here's the unit. If this is mounted against the wall and I want to use this, I can bring it out here and angle the monitor wherever I'm sitting. I can rotate it apparently 360 degrees around if I want, so I can go between landscape and portrait. And it looks like I can also tilt it plus or minus 15 degrees. So that will be something for a future project. So it'll be interesting branching out into electromechanical territory with all these new items. Thanks to Banggood for sending these things to experiment with. As always, thanks to Patreon supporters. Thanks for watching. Come back and see what we got ourselves into in the future.